When we evaluate the future of drone technology, there are a few developments that stand out. One is the emergence of modular drones. And we have seen larger versions of morphable crafts, but it's very plausible we will see smaller versions which are capable of getting into tight spaces. Another is autonomy, not necessarily pre-programmed flights, but real-time analytics and obstacle avoidance. This could possibly lead to a drone which utilizes machine learning, which adheres to the user's objectives. Another strange development is the emergence of passenger drones. This may seem comical at first, but when we look at alternative energy sources, it starts to become more feasible for urban transportation. There will always be a pursuit for making drones smaller, but this leads to unconventional designs and worth a whole entire video which I will cover in the future. But for now, let's look at some of the weirdest drones and see how they are changing the game in the realm of this technology. We begin with the extreme number 7 position, and it's the AB-5 jet prototype. It was only a matter of time until somebody built an actual jet-powered drone. The AB-5 is powered by 4 microturbines and can fly over 300 miles per hour, maybe even faster if it has afterburners. Its tank is good for 30 minutes of hovering, and it can carry a max load of 40 pounds. The drone itself is 50 pounds, so hopefully there is no mechanical failure. As we all know, microturbines are pretty expensive, so the AB-5 is going to retail for around $200,000. So it's time to remortgage your house. Now we get to the unexpected number 6, and it's the Astral Bee. Well, it's not exactly a multicopter, and this drone uses impellers with pressurized air to move. It's basically an autonomous cube, which moves around the International Space Station. The robot can carry a variety of modular payloads, and will eventually be equipped with a modular arm for grabbing onto things, and hopefully not people. Astral Bee uses a combination of RGB, depth cameras, and augmented reality to localize itself, so it's pretty accurate in picking its own paths. Which is probably a good thing because we don't need any kamikaze cubes aboard the ISS. At number 5, the Falcon. A bit reminiscent of the Osprey tiltrotor, the Falcon is a bicopter which can maintain 50-minute flight times. It carries a 3-axis gimbal and your typical flight controller with pre-programmed flight abilities. It also has a stereo camera for obstacle avoidance. I'm going to be a little bit skeptical about these numbers because the company which is actually designing this drone is falling behind on deliveries from their last designed drone. So there definitely is no guarantee about this one, but the retail price will start around $1,000. Now we get to number 4, and there are literally over 100 passenger carrying VTOLs now. And I am a bit perplexed on the emergence of passenger drones, but anyways, here is yet another one. This prototype can carry up to 550 pounds of payload up to 50 miles per hour. It has 12 rotors and can carry a very large battery on its roof, which allows the craft to fly for 20 minutes. Now obviously, 20 minutes is not that long of a flight time, and this really exemplifies the limitations of battery power. And that is why I'm a bit perplexed on this type of energy source, but this also leads me into the next position. We get to number 3, and it's the Sky Passenger Drone. Now if you watched my video about hydrogen vehicles, then you probably have predicted this one. Hydrogen has a higher energy density, so it allows aircraft to have dramatically increased flight times when compared to battery technology. The Sky VTOL utilizes a hydrogen fuel cell, and it achieves about 4 hours of flight time and 430 miles of range. So maybe hydrogen is not that bad after all, especially in aeronautical applications, but you still need a refilling station. Now the Sky can carry 5 passengers up to 118 miles per hour, and it can either fly with a pilot or go into a complete autonomous mode. It also carries a fail-safe parachute just in case it falls out of the sky, no pun intended. At number 2, the Squid. Yes, the days of starting up your electric motors on a level hard surface are gone. The Squid is a bold prototype from Caltech and JPL, which can ballistically be launched from a cannon. It has this ability thanks to its spring-loaded arms, which can deploy in rapid session. Its motors quickly spin up and can orientate the drone into a hovering mode, so the total launch time amounts to less than a second. Now the Squid is totally scalable and can range from 2 to 6 inches in diameter. So maybe this drone will launch from another drone, which is also launched from another drone. And I'm starting to confuse myself, so let's get on to the next position. Now we get to number 1, and it's the Skydial 2. I missed the first version of this drone, but here's the second version of this one, and it's one of the best autonomous drones out there. The Skydial can track the user up to 36 miles per hour, but it also has a built-in omnidirectional obstacle avoidance system. This means it also shouldn't crash into trees and buildings while it's tracking its subject. This drone has built-in navigation cameras and utilizes deep learning. Ultimately, this means that it can fly in very complex environments, with only about 10% more of energy being used in total flight time. With a 4K 12 megapixel camera, its $2,500 price tag is pretty high, but it's also reasonable for this type of system. However, obstacle avoidance will probably be a pretty standard feature in a few years. So it's going to be interesting how autonomy plays out in the world of drones. So once again, thanks for watching. Please like the video if you enjoyed it, and also make sure to subscribe to my channel.